It's not as big for us when it breaks down at least.
Oh, I'm sorry. I was yelling at you before class began. Yeah, it was a little out of my ear. Yeah, you're right. Ow! Put your freaking game away. So.
Sorry. Oh, she's lacking. Hey, I did this. Yeah.
There has to be some of these that I need to go through. So tell me what they are. Number 4. So if I have f of x equals x squared plus 2x, and I asked you for like f of 2, let's not use 2, let's use 3. What would you do with the 3? Plug it in for x, right? So basically the idea is that because the 3 went in for that x, the 3 has to go in for that x and that x. Well, if I have f of ln of x, it works the same. So this will become ln of x squared plus 2 times ln of x. So I'm plugging ln of x into f. So anywhere I see an x, I'm putting the ln of x in that spot. Does that make sense what I'm doing there? Yeah. And then it's like chain rule. So from that point, you got 2 is your big guy, bring it down, reduce by 1, you leave the inside alone. Then you multiply by the derivative of the inside, so your g prime piece, so this is 1 over x. Plus, so that 2 in front of a function, just 2 just drops, then what's the derivative of the ln of x? Is 1 over x. So, like I know that's not going to be there, so I'm just going to start to clean it up a little bit and see what happens. So this looks like I can rewrite as 2 ln of x over x, and this I can write as 2 over x. Circle. It's like closed and opens. You can't even tell.
If we were so far, if we were on the anywhere, whatever, with the rules you provided now,
that would be okay. Yeah. So far, that might change, but I'll let you know. Obviously. Yeah. Is that okay? 37.
No, we did, but I don't know if it was like.
So it's actually similar. So like f of x is, I would write it as x squared minus 4 to the 1/2. And then I want to know what f of g of x is so I can take the derivative. So, like, again, just as an example, like f of 10 would be plug in 10 squared minus 4 to the 1/2. Well, f of g of x means plug g of x in. And then I know what g of x is. So I can get to that. You with me? To that part? So then, basically it's like y equals that stuff. And I gotta take the derivative of that. So, my big guy is this 1/2 power. My next biggest guy is this squared. And then I've got the 3x minus 2. So I'm going to do the big guy first. So the way you take the derivative of a power is to bring it down and reduce by 1. And then I leave the stuff on the inside the same. So that's my f prime and my g. So now I go to g prime. So g is technically all of this stuff that's being square rooted. But the minus 4 is not really going to matter, right? Because that's just the derivative of 0. So g is this squared. Bring down the 2. inside of that. 3x minus 2. So I've done the big, I've left the middle, and the little alone. Then I did the middle derivative, I left the little alone. And then finally I get to the derivative of the little. And then they're asking you to plug in 3. So there's 2 approaches you can do here. One would be to simplify everything first. Take a bunch of time, possibly make a mistake in simplifying, and then plug in 3. If you can't tell, I don't recommend that route. I recommend you just plug in now. And then it's easier for most people to simplify once there's numbers there than when there's a bunch of variables and stuff. So I'm going to plug in 3 right here. So 1 half times, this is 3 times 3 minus 2 squared minus 4. So the negative 1 half is a beast. 2 times 3 times 3 minus 2 times 3. Okay? You with me so far? We're I can clean this up a little bit. Like 1 half times the 2. If I multiply 1 half times 2, those just go away. So that's kind of nice. If I look at what's in here, so 9 minus 7 is 2. 9 minus 2 is 7. 7 squared is 49. Minus 4, so I have 45 to the negative 1 half times 9 minus 2 is 7 times 21. Good God.
Yeah.
So this is why the AP does just a bunch of jerks. Like, I did the calculus, I'm right, and now you're making me jump through your hoops. Okay, so they got this, like, I don't see a 21 square rooted, right? So even if I know nothing else at this point, I'm pretty convinced that they're just trying to trick me because the square root is on this part, not this part. So I'm going to get rid of those. And then my next thought is I'd see that, like, square root of 5 on the bottom. I was like, knock those out or what? Try to get rid of those. Alright. So then I noticed this square root of 5 on the bottom of these. And I'm like, how could I get to 5? So I realized there's a square root here, and I'm like, could I get a 5 out of this somehow? And I realized it, so first of all, could I rewrite it like this? That's the same thing, right? So I'm putting the square root of 45 on the bottom. And then all they're doing is saying, well, the square root of 45, you could really write that as the square root of 9 times 5. 9 times 5 is 45. And then the square root of 9 is 3, so you can, like, yank that part out. And then 20 over 1 over 3 reduces to 7 over 1. That's a beast. That's about as tough a one as I could come up with, unless I get, like, trig involved and stuff. But that's a lot of stuff. Like, I didn't even read the problem when you asked me at first. I was just, like, doing it, and I didn't see this. It seemed reasonable. When I realized I'm plugging 3, that seems like that's a lot. But it's all doable. It just takes time. Well, gotta be more. So let's add 4e to the negative 4x. Like, let's just put an a there. Like, I'm going to ask you a 4 as a number, and I'm putting it in for a. So I'm going to go through with this, then we'll go through it again with the a's, just like check it. Is this a product rule problem? Product rule, you want like a function of x times another function of x. Do I have that here? The thing with an x in it times the thing with an x in it. I don't. I just have like one thing with an x in it. Some people think it's product rule because the number in front. But remember, when you have a number in front of like a trigger and a land, what happens to it? It just comes straight down. So that 4 just comes straight down. Then I've got to take the derivative of e to the negative 4x. So that's a chain rule. What's your big guy? The big guy is actually the e. And the little guy is the negative 4x. Because e is raising, it's like controlling the negative 4x. So the derivative of e is e. So I put the e there, and then what do I do with the little guy? I don't know why I put it there. This is my f prime. Like I've done the derivative of the big guy. So after f prime, what comes next? So the derivative of f of g of x equals f prime of g of x times g prime of x. That's your chain rule. So the 4 dropped, that was not chain rule. This e down to this e is me taking the derivative of e. So that's my f prime. What do I do with g of x? I leave it. Keep it. So that negative 4x still goes there. And then I get to g prime. So what's the derivative of negative 4x? It's negative 4. So if I do that with a's, so if I have y equals, if I have y equals a e to the negative ax, so the same idea, that's a constant in front of a function, so it's going to drop down. E is your big guy, negative ax is your little guy. So the e stays. Derivative of e is e. That's my f prime. G of x stays, so negative ax stays there, and then I multiply by the derivative of that top piece, which is negative a, and then they got some like simplifying, so it's negative a squared when you multiply these two together, and then e to the negative ax. How's that, Trey? What else? What else? Yeah, right there. Oh, you're gonna be frustrated. So if I have there's like a hard way to do this, but the easy way is what happens to ln's and e's. So technically here, you can rewrite it as 2x times ln of e. Those cancel out, so y equals 2x, and what's the derivative of 2x? Is 2. Does that make sense? Do you want me to go through like the chain rule there? Yeah, no, it does. But okay, what else? Yeah. Okay, f of 2, f is the okay, so they're giving you a composite function here. So this h, so they're saying h is a differentiable function. So it could be cosine, it could be squared, it could be square rooted, it could be an e. What they're saying is that is like your big guy. Batteries, you can see the lag that's there. And then this is your little guy. So I'm going to take the derivative of that. Yeah, what you do? Am I?
Yeah, you take the derivative of h, so it's h prime times x squared minus 3.
Right, like chain rule.
Yeah, and then you take the derivative of the inside, so that's multiplied by 2x, and you set that equal to f of 2. So you plug in 2, but they never give you h prime. So what they're asking is for you to, like, so you plug 2 in, so it's 4 minus 3, which is 1. And then you plug 2 in with the multiplied by 2x, so you get 4 on the outside, so it's 4h prime time, to 1.
But why are we plugging 2 into f prime if it's asking us for f? Like, I agree with you, that
Yeah.
works. That's what I did in my head at first. So if I went f prime of 2, it'd be like h prime times 4 minus 3
Yeah.
times 4. So yeah, you're going to get this 4 times h prime of 1. But that's f prime of 2. That's why I was getting stuck. I'm just going to assume
Yeah.
what they meant.
I would hope so.
Yeah, I think that's what they meant. Because there's no way I can find f of 2. I don't know what h is to go with. So that's the best answer I can give you. I think that's what they were asking for. Does that part make sense? Like just chain rule this and then plug in 2. So say it again.
Isn't f of 2 just h of 1? If the original function, if you plug in 2, you get h of 4 minus 3, which is h of 1. So then the derivative of that is your h prime of 1.
So h prime of 1. No. I was good to move on before this. Now you're bringing another twist into the wind here. So, okay, so f of 2 equals h of 1. I don't disagree with that, but what is that?
Doesn't that mean that that f prime of 2, well, no, that's 1.
Because this is a prime.
I'm just thinking they made a mistake.
I think they just made a mistake.
This is good. This is something we've learned, so why would they just pull this out?
There is a
There is a
smudge next to the
smudge,
F.
next to
Like if you look at the top of the F, there is a smudge.
Oh, there is.
So that yeah, maybe. If it asks for the derivative, it's a perfectly normal question. We did it right. I'm just so sorry.
It's like the question this morning in 10B or whatever.
Okay, let's pick it. Let's do a different one. Well, you know.
We're talking about how the 10 this morning was just 2. They gave
Right. But you don't want me to do number 2. Okay. I'll leave it there then. This is just more practice. And tomorrow we're moving on to implicit differentiation. And I just printed the extra practice on the website. And there's 2 of them, so I printed both. I'm not collecting both. You feel like you're good. Probably just do one extra practice, do both. And this is kind of all the plan, all the time I'm planning to spend on chain rule